The technical term of what we're going to be doing today is called sinusoidal curve fitting. Okay? Basically, what's going to happen today is you're going to be in one of two situations. Okay? The first situation is we're going to give you a curve. And we're going to ask you to come up with the function for that curve. Okay? So it could be a sine curve, or you might think that a sine curve fits it best. You might think that a cosine curve would fit the best. You might be told which curve to find. Okay? We might say, find a sine curve, find a cosine curve for this scenario. Okay? You might be told. Okay? The second scenario that we're going to have is we're going to give you a certain amount of data points. And we're going to ask you to find a curve based off of those data points. Okay? In either case, your function is going to, there it goes. Your function is going to be of y equals a sine or cosine of b x minus c plus. It's going to look like that. Okay. A, remember, that's our amplitude. Okay. B deals with our period. C is our start, and D is our middle. Okay? So those pieces of 9 that we've been dealing with, we had the domain, we had the middle, the low, the high, amplitude, and the range. We had the start, period, and the end. Those were our pieces of 9. Okay? We're going to want to find all of those. This is still on that first page. Okay? Trust me, still on that first page. Okay? We're going to want to find all of those before we get to our function, because it's going to make finding our function relatively simple for us. Okay? All right? So let's jump into, this is that first graph on the top of your page. Okay? We want to find a sine curve for that one. Okay? So how we would go about this is we would have to take a little peek at our graph. Okay? So sine, okay, we would know that it's got a high value and it's got a low value, right? Okay? And we can get that right off of our graph. Okay? So what is the high value, the maximum value of our on this graph of our function? Yeah. -1. -1? -4. Yep, -4. Okay. So up here, this is the high. Okay. So now let me move that over a little bit so we can see it. There we go. What's the low value? On this graph. If you can't read it all the way up here, it's literally in front of you. We got so -16. I love it. So that's our low down there. Okay. How am I going to be able to find the middle? If my high is -4, my low is -16. How would I find the middle? I'd average those two. Yep. My middle here is going to be -4 plus -16 divided by 2. I'm going to average those two. -4 plus -16 is -20. -20 divided by 2 is -10. Right? Now that's important for us because that value, that's my D value. That's my middle. My middle is my D value. Okay? My amplitude, well, actually, let me put my middle here on here. So my middle is right there. Okay? Now my amplitude is the distance from the middle to the top or the middle to the bottom. So this distance right here, that's my amplitude, or right there. That's my amplitude. So my amplitude is 6. Yep. That's important because that's A. Sine. We got to find sine on this one. We want to find sine on that one. So sine, where does sine start? Low, middle, or high? Starts in the middle, right? And then goes to the high, back to the middle, low, and ends at the middle. Okay? So I need to start in the middle with my curve going up. So my start here would be at -1. So that my first lap wave is that one right there. Okay? So if I start at -1, then the horizontal distance that it takes me to make that wave would be my period. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That tells me that my period here is 12. Now, we learned a formula last week that said that the period was equal to 2 pi divided by b, correct? Well, if I solve that for b, because I want to find b, I would just flip-flop b and my period. So b is equal to 2 pi divided by the period. Back up to here, b would equal 2 pi divided by my period of 12. So b would be equal to pi over 6. So that's b. And this is C. Now I've got A, B, C, and D, which is what I need to make my formula, or to make my equation. So my sine equation would be y equals, my a value was 6, sine of, my b value was pi over 6, x minus, my c value was -1. So minus a -1 is like +1. My middle, my d value was -10. And that is my function. Now, what if, instead of starting there, if we would have started right there? Does my amplitude change? No. Does my middle change? No. Does my b change? No. The only thing that changes is c. So we could have written this as y equals 6 sine of pi over 6 times x minus 11 and minus 10. Like that. We can change our starting position. We can change our starting position. What if we started there at that middle? Now we're on the downward slope, right? So then our a has to change. That one is 5. Fear not. You only got to come up with one of them. Okay? One of those are, there's an infinite amount of formulas that are equations that you can come up with that'll all be the same. Okay? You only got to come up with one. We as the teachers have to come up with the rest of them. Okay? So when you put yours down, I've got to really look at it and see, okay, you starting in the middle as it's going up or in the middle as it's going down? Are you starting at the first one that you see or the second one that you see or the third one that you see or so on and so forth? Okay? Handle? Love it. Okay? For that bottom one, I want you to try now and find me a cosine curve to go along or to fit that function. Okay? Go for it. My high value is 7. My low value is -3. That puts my middle at 2. Because 7 plus -3 divided by 2 is 2. Agree? That also makes my amplitude be 5. 5 to get from 2 to 7, 5 to get from 2 down to -3. Okay? Cosine starts on high, so I could start there, and I would start at -2. It ends on high, which would be right there, and that would be at 6. which gives me a period of 8. So B is going to be 2 pi divided by my period. 2 pi divided by 8 is pi over 4. Yes? A, B, C, and D. Yep, got them all. Okay. So one function could be y equals, my A value was 5, cosine of pi over 4, x minus negative 2 plus 2. Yes? That's one of them. Another one? Oops, not plus. Minus 6. Yes? Another one? Oh, I put minus 6 again. 3 minus 14. Yes? Another one? Oops, nope, minus 2. That last one starts here. Because it's negative. Yep. Yep. Okay. Love it. If you flip that page over, we can go through the second part. Okay? The second kind of problem is where we give you some data and we ask you to find a sine curve or a cosine curve, a sinusoidal curve, to fit that data. Okay? So first off, it never hurts to graph your data. Yeah. So if we start at the 0 hour, which we'll call 12 a.m., we'll call that the 0 hour, okay? Because really it's hour 0 of the day. The depth of the water was 2.55 meters. Okay? So let's go 1, 2, 3, 4, something like that. Okay? So 2.5 meters depth at the 0 hour. We're right about that. At 2 a.m., the depth was 3.8. At 4 a.m., it was 4.4. At 6 a.m., it was back to 3.8. At 8, first thing you got to ask yourself is self, sine or cosine? Looks like sine to me, right? Okay. Let's go sine. Okay. Then you need to find the middle. So it appears that 4 a.m. is the high. Okay, because it said right here, high tide is at 4 a.m. And 10 a.m. is the low tide. So what's the average of those two? $5.46.2 divided by 2, right? So that's 3.1. And that's going to be our D. From that, we can get our amplitude. Actually, what we should do is we should put the middle line on our graph. One, two, three. So that's our midline. Over there, that's on the other side. Okay. So what is my amplitude then? If my middle is 3.1. 1.3? And that's important because that's A. Okay? If I were to draw in just that function, right? Just that little part of the function, that tells me that here is my start, which appears to be about 1. Correct? If I continue on with this function, it would appear, actually it would kind of come up here more. It would appear that I would say like at 13 would be my end-ish. It's a little past 12, right? I would say the 13th hour. Yep. Or 1 p.m. Yep. Okay. So that makes my period be 12, right? So period equals, oops, not period, excuse me, B is going to be 2 pi divided by 12, or pi over 6. So my function here, I can write now, y equals, my a value is 1.3, we said sine, I won't put cosine, pi over 6, x minus 1 plus 3.1 as my function. Because my start was at 1. Because that's where my graph, or where my, if I connected, if I draw in my curve, that's where my curve crosses the midline. Okay? It's not always going to be at time 0. Okay? Agreed. Yeah? Okay. And that's our function. And now what we can do is we can use our function to find the depth at different times on our graph, or during this data set. Okay? So at 9 a.m., I can either go up to my graph, and I can utilize it. If I go up to my graph at 9 a.m., I would be somewhere right about there, which puts me somewhere right around 2. Agree? Okay? To find it exactly, we would use a calculator. And so we would take 1.3 times the sine of pi over 6 times 9 minus 1, and then plus 3.1. Now the kicker here, before you guys are punching in your stuff, you gotta make sure that your calculator is in radians. You gotta make sure that your calculator is in radians in order to do this. So that's a DRG. If you slide it over to the RAD, if you're using this kind of calculator, or in your, if you're using an Inspire, it's in the setting. Okay. 1.3 times the sine of, open parentheses, pi over 6 times 8. We can just do 8 there. And then plus, syntax error. Syntax error. No, it must not like that. Okay. Times the sine of pi divided by 6, close parentheses, times 8, close parentheses, plus 3.1. I get 1.974. Agree? Yes? Okay. Now at 3 p.m., that's actually going to be hour number 15.
I have my lunch cup.
Yep, I know. Okay. That's actually going to be hour 15. So we're going to plug in 15 there into our formula. Again, making sure that we are in radians. This was the, so that was 14. And there I get my depth as 4.226 meters. Yes? Okay. I think that that is a good spot for us to stop this evening, or this, I almost said this evening. Today.